In this video, we'll be solving the May June 2023 question paper 53. That's Probability and Statistics 1 for the CIE A Level Maths 9709 exam board. Subscribe and let's get into it. Number 1. Two fair coins are thrown at the same time repeatedly until a pair of heads is obtained. The number of throws taken is denoted by the random variable x. Part A. State the value of the expectation of x. If we go back to the stem of the questions, we are told that two fair coins are thrown at the same time repeatedly until a pair of heads is obtained. So that tells us that x follows a geometric distribution, right? And we're told that the number of throws taken is denoted by the random variable x. So the probability of obtaining a pair of heads on throws of two fair coins would be 1 over 2 times 1 over 2, which is a quarter, and I'm going to write that as 0.25. And to get the expectation under a geometric distribution, our formula is 1 over p, so that's 1 over 0.25. So the expectation of x is equal to 4, and that's our final answer. Part B. Find the probability that exactly 5 throws are required to obtain a pair of heads. So the probability that x is equal to 5. So this is the probability of failure, 0.75 to the power of 4 times the probability of success, which is 0.25. Let's punch this into the calculator. So that is 0.75 to the power of 4 times 0.25, and that gives us 0.0791, and that's our final answer. Part C. Find the probability that fewer than 7 throws are required to obtain a pair of heads. So the probability that x is less than 7. Since this is a discrete distribution, we can then write this as less than or equal to 6. And this allows us to use the formula. The probability that x is less than or equal to r is equal to 1 minus q to the power r. So in this case, that's 1 minus q is 0.75 and r is 6. So we can punch this into the calculator. That is 1 minus 0.75 to the power 6. And that gives us 0.822. And that's our final answer. Number 2. Anil is a candidate in an election. He received 40% of the votes. A random sample of 120 voters is chosen. Use an approximation to find the probability that of the 120 voters, between 36 and 54 inclusive voted for Anil. Okay, so let x be the random variable, number of voters who voted for Anil. Okay, so x initially follows a binomial distribution and the n is 120. The probability of success, they said 40%, so let's write that as 0.4. And now we're required to use an approximation. At AS level, the only approximation we'll use is a normal approximation to the binomial distribution. So we know that x follows a normal distribution and our mean will be NP and our variance is NPQ. So let's evaluate NP. NP is equal to 120 times 0.4. So if we punch that into the calculator, 120 times 0.4, that gives us 48. And NPQ, that's 120 times 0.4 times 0.6. So NPQ is equal to 120 times 0.4 times 0.6, and that gives us 28.8. So we know that x follows a normal distribution with mean NP, that's 48, and variance NPQ, 28.8. And the question requires us to find the probability that of the 120 voters between 36 and 54 inclusive voted for unknown. So what this means is that this is between x is between 36 and 54, but they used the word inclusive. So that means we are including both our boundaries. It's 36 is being included as well as 54 being included in this range. Now note that this statement is defined under a discrete distribution. So since we have approximated to a continuous distribution, which is the normal distribution, it means we have to apply continuity correction. So 36 represents values between 35.5 and 36.5. And then 54 represents values from 53.5 to 54.5. So we'll start with the 36. They said x should be greater than or equal to 36. So since we want to include the 36 as well, we're going to take its lower bound. So x is greater than 35.5. Then for 54, x is less than or equal to 54. We want to include all of 54 as well. So x should be less than 54.5. So putting everything together, this means we are evaluating the probability that x is between 35.5 and 54.5. And now we can standardize and evaluate our probability. So this becomes 35.5 minus our mean, which is 48, over the square root of 28.8, and this is z, then 54.5 minus 48 over the square root of 28.8. And so this is the probability that, let's punch that into a calculator, 35.5 minus 48 over the square root of 28.8, and that gives us negative 2.329, and this is less than z, which is less than, so that's 54.5 minus 48 over root 28.8, and that gives us 1.211. And we can write this as phi of 1.211 minus 1 minus phi of 2.329. And then let's use our normal distribution tables to get our values. So that's 0.8871 minus 1 minus 0.9900. And so if we simplify this, that's 0.8871 minus 1 minus 0.99. That gives us therefore 0.877, correct to 3 significant figures, and that's our final answer. Number 3, the random variable x takes the values 1, 2, 3, 4. It is given that the probability that x equals x is equal to kx times x plus a, where k and a are constants. Part A, given that the probability that x is equal to 4 is equal to 3 times the probability that x is equal to 2, find the value of a and the value of k. We're given that we have a random variable x that takes on the values 1, 2, 3, 4. And we're given that the probability that x is equal to kx times x plus a, and then we're also given that the probability that x is equal to 4 is equal to 3 times the probability that x is equal to 2. Okay, so let's start by evaluating the probability that x is equals to 4 using the formula that they gave us. So that's k times x, which is 4, times 4 plus a. So the probability that x is equal to 4 is equal to, let's expand out the brackets, that will become 16k plus 4ak. And then we also have to evaluate the probability that x is equal to 2. So the probability that x is equal to 2 is equal to k times 2 plus a. And if we expand everything, that's the probability that x is equal to 2 is equal to 4k plus 2ak. Now let's evaluate this equation. That is the probability that x is equal to 4, which is 16k plus 4ak. And this is equal to 3 times the probability that x is equal to 2. So that's 4k plus 2ak. So that's 16k plus 4ak is equal to 12k plus 6ak. Let's put everything on one side and simplify. So 16k minus 12k plus 4ak minus 6ak, that's equal to 0. So what we have is 4k minus 2ak is equal to 0. Let's factor out 2k. So that's 2k, 2 minus a, and this is equal to 0. So what we have is 2k is equal to 0, and then 2 minus a is equal to 0. So this becomes k is equal to 0 and a is equal to 2. We know that k cannot be equal to 0, because if k is equal to 0, then that makes this whole formula invalid, and then we won't be able to get probabilities for x is equal to 1, 2, 3, or 4. So since we know the value of a, we can then use that to get our value of k. And how we're going to do this is we're going to use the probabilities. We know that the probabilities that x is equal to x, the sum of all of them will add up to 1. So if we evaluate the probability that x is equal to 1, 2, 3, and 4, we should get 1. So we need to first find the probabilities in terms of k and a. So we're going to use the formula. We already have probability that x equals 2 and x equals 4. So we need to find the probability that x equals 1 and the probability that x equals 3. So x equals 1 will become k times 1 plus a. So if you expand that, that gives us k plus ak. And then the probability that x is equal to 3 is equal to k times 3 plus a. So that becomes the probability that x equals 3 is equal to, that's 9k plus 3ak. Now let's put all the probabilities together. We say the probability that x is equal to 1, 2, 3, 4, all add up to 1. So let's write it below where we have more space. So this is the probability that x is equal to 1, 2, 3, 4, and that adds up to 1. So x equals 1 is k plus ak, k plus ak, and then x equals 2 is 4k plus 2ak, x equals 3 is 9k plus 3ak, and then x is equal to 4 is 16k plus 4ak plus 4ak, and they all add up to 1. Okay, so let's add the like terms. So we've got k plus 4k, that's 5k. That makes it 14k, and then that's 30k. So we've got 30k, then ak This becomes 3ak, 6ak, and 10ak plus 10ak, and this is equal to 1. We already evaluated a to be 2, so we can say 30k plus 10 times 2 times k is equal to 1, so 30k plus 20k is equal to 1, so 50k is equal to 1, therefore k must be equal to 1 over 50. Therefore, we can conclude that a equals 2 and k is equal to 1 over 50. Part B, draw up the probability distribution table for x given the probabilities as numerical fractions. Okay, so in part A, we evaluated our probabilities in terms of a and k. Now that we have the values of a and k, we can evaluate them and get them as numerical fractions. So we'll start with the probability that x equals 1, and that was k plus ak. So k plus ak. So if we substitute k and a, that becomes 1 over 50 plus 2 times 1 over 50. So what that gives us is that's 3 over 50. And let's evaluate the probability that x is equal to 2. So that's 4k plus 2ak, 4k plus 2ak, and that's equal to 4 over 50 plus 2 times 2 times 1 over 50. So that gives us 4 over 50 plus 4 over 50, which is 8 over 50. And now the probability that x is equal to 3. So that's 9k plus 3ak. And so that's 9 over 50 plus 3 times 2 times 1 over 50. So that's 9 plus 6, which is 15 over 50. Then with the probability that x is equal to 4, and this is 16k plus 4ak, and so that's 16 over 50 plus 4 times 2 times 1 over 50. So that's 16 plus 8, which is 24, and that's over 50. Now we can draw our probability distribution table since we've evaluated our probabilities as numerical fractions. So that's x, and the probability that x is equal to x, and we've got 1, 2, 3, and 4. So 1 is 3 out of 50, 2 is 8 out of 50, and 3 is 15 over 50, and 4 is 24 over 50. And make sure to draw this with a ruler, as well as make sure to close all the cells of the table. Part C, given that the expectation of x is equal to 3.2, find the variance of x. So var of x is equal to the summation of x squared p minus the expectation of x squared. So we need to first find the summation of x squared p. We already have the expectation of x. So this is using our probability distribution table. That's 1 squared times 3 over 50 plus 2 squared times 8 over 50 plus 3 squared times 15 over 50 plus 4 squared times 24 over 50. And let's punch this into the calculator. So that's 1 squared times 3 over 50 plus 2 squared times 8 over 50 plus 3 squared times 15 over 50 plus 4 squared times 24/50, and that gives us 11.08. So we can now go back to the formula for variance and say 11.08 minus 3.2 squared, and punch that into the calculator. 11.08 minus 3.2 squared, and that gives us 0.84, and this is our final answer. Number 4. The times taken in minutes to complete a cycle race by 19 cyclists from each of two clubs, the Cheetahs and the Panthers, are represented in the following back-to-back stem and leaf diagram. Okay, part A, find the median and the interquartile range of the times of the Cheetahs. So since we have 19 cyclists, our median position will be 19 plus 1 over 2. We're using the formula n plus 1 over 2 to get the median position. So our median position is number 10. So if we count the Cheetahs, remember that using our key, this is 78, 79, 80, 82, 83. So we count going upwards from right to left. It's counterintuitive. You'd expect to count from left to right, but when you're using a stem and leaf diagram, for the left hand side, we're going to count from right to left. So for the Cheetahs, we want to count up to position 10. That's where our median is. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's our median position, and that's at 99. We can say that Q2 is equal to 99 minutes. Okay, and I'm going to use a different color for our interquartile range. So interquartile range is equal to upper quartile Q3 minus lower quartile Q1. So let's start by getting the position for a lower quartile. We use the formula a quarter times n plus 1. So that's a quarter times 20, and that gives us 5. So 1, 2, 3, 4, 5. So 83 would be Q1, and then we want Q3. To get Q3's position, that's 3 quarters times 20, which is 15. So since this is 5, that's 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So 106 will be our Q3. 106 minus 83 for our interquartile range. Punch that into a calculator, you get 23. So therefore, Q2 is 99 minutes. 99 minutes, and our interquartile range is 23 minutes, and this is our final answer. Part B, the median and interquartile range for the Panthers are 103 and 14 minutes respectively. Make two comparisons between the times taken by the Cheetahs and the times taken by the Panthers. Remember that we're talking about time, so a shorter time refers to the Cheetahs being faster. So the less time they took, the faster they were. So in this case, since the median for the Cheetahs is shorter, we can state that the Cheetahs are faster than the Panthers. Are faster than the Panthers. And then now let's compare the interquartile range. Since the interquartile range for the Cheetahs is greater than the interquartile range for the Panthers, we can state that the times for the Cheetahs are more spread out since they have a larger interquartile range. So the Cheetahs times are more spread than Panthers. And those are our two comparisons. Another cyclist, Kenny, from the Cheetahs also took part in the race. The mean time taken by the 20 cyclists from the cheaters was 99 minutes. Part C, find the time taken by Kenny to complete the race. Okay, so our mean for all 20 competitors will be the summation of the first 19 competitors plus, we'll say x20 to represent Kenny, or over n, which is 20. So we're saying the mean is equal to the total times taken before Kenny plus Kenny's time over the total number of cyclists. So our x bar here is, we are given that it's 99 minutes, 99. And then the summation of x, we can evaluate that by adding all of these numbers over here. That's going to be very tedious. We are dealing with the cheaters, okay? So let's get our summation of x. Summation of x for the cheaters. So that's 78 plus 79 plus 80 plus 82 plus 83 plus 87 plus 88 plus 97 plus 98, 98 plus 99 plus 101 plus 103 times 2 plus 105 plus 106 plus 112 plus 118 plus 119 plus 124. That's a lot. Okay, so let's punch that into the calculator. That's 78 plus 79 plus 80 plus 82 plus 83 plus 87 plus 88 plus 97 plus 98 plus 99 plus 101 plus 103 times 103 times 2 plus 105 plus 106 plus 112 plus 118 plus 119 plus 124, and that gives us that the summation of x is 1862. Okay, so let's go back to our question. So x bar is 99 minutes, so 99 is equal to our summation of x, that's 1862, plus x20, that's what we're looking for, Kenny's time. And then let me draw that properly. And then with n, which is the number of cyclists, that's 20. So multiply both sides by 20 to get rid of the denominator. You get 1980 is equal to 1862 plus x20. So x20 must be equal to 1980 minus 1862, and that gives us 118, and this represents Kenny's answer, Kenny's time rather, and that's our final answer. Number 5. Jasmine throws two ordinary fair six-sided dice at the same time and notes the numbers on the uppermost faces. The events A and B are defined as follows. A is the sum of the two numbers is less than 6, and B is the difference between the two numbers is at most 2. Okay, part A, determine whether or not the events A and B are independent. We're going to draw a possibility space diagram that shows all the possible outcomes. So it would look something like that. We have two ordinary fair six-sided dice. So this is our first die here. And so we've got 1, 2, 3, 4, 5, and 6. And then our second die will be here. That's 1, 2, 3, 4, 5, 6. So I'm just going to draw dots here. Okay, now we have to evaluate event A. So event A We'll represent that in red. In fact, let me write a key first. So our key will be that event A is, it will look something like that, and then we'll put a red circle on top of that blue dot. So we want the sum of the two numbers to be less than 6. So this 1 plus 1 is less than 6, 2 plus 1, 3 plus 1, 4 plus 1, 5 plus 1 is equal to 6, so that doesn't satisfy our conditions. 2 plus 1, 2 plus 2, 2 plus 3, and then 3 plus 1, 3 plus 2, and then we've got 4 plus 1, and those are all the scores that, and those are all the sums that are less than 6. Now let's write our key for B. B will be, let's use gray. So that's a blue dot encircled by a gray circle. Okay, so B is the difference between the two numbers is at most 2. Okay, 1 and 1, the difference is 0. 2 and 1, the difference is 1. 3 and 1, the difference is 2. Those are all. And then we've got 2 and 1, 2 and 2, and then 3 and 2, and then 4 and 2. And then we've got 3 and 1, 3 and 2, 3 and 3, 3 and 4, 3 and 5. And then we've got 4 and 2, 4 and 3, 4 and 4, 4 and 5, and then 4 and 6. And then we have 5 and 3, 5 and 4, 5 and 5, 5 and 6. And then we've got 6 and 4, 6 and 5, 6 and 6. And that's everything. Now let's write down the key for the intersection. A intersection B, that's a blue dot circled by a red circle, which also is encircled by a gray circle. Okay. We know that for the events A and B to be independent, the probability of A intersection B should be equal to the probability of A times the probability of B. So the probability of A intersection B according to our key, that's a blue dot circled by a red circle and then a gray circle. So we've got 1, 2, 3, 4. We've got 1, 2, 3, 4, 5, 6, 7, 8. So we've got 8 out of 36 because that's 6 times 6. And then event A, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 out of 36. And then event B, that's gray circle. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So that's 24 out of 36. So we've got 8 over 36. And if we simplify the right hand side, that is 10 over 36 times 24 over 36. That gives us 5 over 27. So clearly the intersection is not equal to the product of events A and B. So that means that events A and B are not independent, and that would be our final answer. Part B, find the probability of B given A complement. Okay, so the formula for that, probability of B given A complement, that is equal to the probability of A complement intersection B over the probability of A complement. So A complement just means the exact opposite of A. So since we have the probability of A, we can say that the probability of A complement is 1 minus the probability of A. So the probability of A complement is equal to 1 minus 10 over 36, and that is equal to 26 over 36. Okay, so now we have to find the probability of A complement intersection B. So this is basically everything that's outside of A and it intersects with B. So in other words, that's everything that's only circled by the gray circle. So if it looks like that, that's what we want. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16. So that's 16 out of 36. 16 out of 36, and now we can go back to our formula for conditional probability. That is the probability of A complement intersection B, which is 16 over 36, divided by the probability of A complement, which is 26 over 36. And if we punch this into our calculator, that is 16 over 36 divided by 26 over 36, and that gives us 8 over 13, and that is our final answer. Number 6. The mass of grapes sold per day by a large shop can be modeled by a normal distribution with mean 28 kilograms. On 10% of days, less than 16 kilograms of grapes are sold. Part A. Find the standard deviation of the mass of grapes sold per day. So let's start by defining our random variable x, and that is the mass in kgs of grapes sold per day by the large shop. So x follows a normal distribution with mean 28 kilograms and variance is sigma squared, and we're given that when x is less than 16, the probability of x being less than 16 is equal to 0.10. So we can standardize, that would be z is less than 16 minus 28 over sigma, and this is equal to 0.10. If we sketch our bell curve, it looks something like that. This is 0, and we're saying less than 16 is equal to 10%. So that will be this region here, that's 10%, 0.10. And we have our z value. From here we can tell that z is going to be negative. Since we have standardized, this 16 minus 28 over sigma is equal to this negative z that we'll get over there. Let's just simplify this first before we evaluate our z value. So that's negative 12 over sigma is equal to negative z. So using the tables in reverse, we can say arc-phi of 1 minus 0.10. Since our table starts with areas greater than 0.5, we have to use arc-phi of, in this case, that's 1 minus 0.10, which is 0.90. So the z value at 0.90 is equivalent to 1.282. So we can then substitute that here. That's negative 12 over sigma is equal to negative 1.282. And so sigma is equal to negative 12 over negative 1.282. Punch that into a calculator. That is 12 over 1.282. And that gives us 6,000 over 641. So therefore sigma is equal to, now we'll round it off to 3 significant figures, and that's our final answer. The mass of grapes sold on any day is independent of the mass sold on any other day. Part B, 12 days are chosen at random. So whenever you see a statement that says something like this, n days are chosen at random, immediately what should come to your head is that we're going to a binomial distribution. So if we're going to define y as the RV, let's read the rest of the question. Find the probability that less than 16 kgs of grapes are sold on more than 2 of these 12 days. Okay, so we know that y represents the number of days on which less than 16 kgs of grapes are sold. Grapes are sold. So y follows a binomial distribution with n as 12, and our probability of success, that's the probability that less than 16 grapes are sold. And we were given that in the stem of the question to be 10%. On 10% of the days, less than 16 kgs of grapes are sold. So our probability of success is 0.10. And we want to find the probability that on more than 2 of these days, so y is greater than 2, and we can write this as 1 minus the probability that y is less than or equal to 2. So that is 1 minus, let's put a big bracket here, 12 choose 2 times 0.10 to the 2 times 0.90 to the power 10 plus 12 choose 1 times 0.10 to the power 1 times 0.90 to the power 11 plus 0.90 to the power 12. Let's punch that into a calculator. 1 minus 12 choose 2 times 0.1 to the power 2 times 0.9 to the power 10 plus 12 choose 1 times 0.1 times 0.9 to the power 11 plus 0.9 to the power 12. Let's close our bracket. That is 0.111, and that is our final answer. Part C. In a random sample of 365 days, on how many days would you expect the mass of grapes sold to be within 1.3 standard deviations of the mean? Okay, so if this is within 1.3 standard deviations of the mean, this means that we have negative 1.3 and 1.3. And so from here, if we were to sketch our bell curve, what we're looking at is negative 1.3 and 1.3 over here. And we should have our 0 somewhere there. So that will be 2 phi of 1.3 minus 1 to get that area. And phi of 1.3 using our normal distribution tables is 0.9032. So let's punch this into the calculator. 2 times 0.9032 minus 1, and that gives us 0.8064. So this is the probability of one day where we have a mass of grapes sold being within 1.3 standard deviations. But we are given a sample of 365 days, and we want to know how many of those days would we expect to have a mass within 1.3. So what we'll do is say 0.8064 times the 365, and that will give us 294.336. For days, we always round up. So 295 days will be our answer. Number 7, part A. Find the number of different arrangements of the 10 letters in the word Casablanca in which the two C's are not together. Okay, so what we can do to get that is we can say the total arrangements when there are no restrictions, total arrangements minus the arrangements. In fact, let me just not write the word arrangements, minus the arrangements in which the C's are together. So if we subtract the C's being together from the total arrangements, where there are no restrictions, we get the total arrangements in which the C's are not together. So let's start by finding the arrangements in which the C's are together. So that's C and C together, and then we have an A, an S, another A, a B, an L, another A. How many A's are here? N and another A. Okay. So if we count the number of underlines, that's 1, 2, 3, 4, 5, 6, 7, 8, 9. That would be 9 factorial. And then the repetitions 1, 2, 3, 4, that's 4 A's. So over 4 factorial. Are there any more repetitions? Nope, that's all. So let's evaluate this. That is 9 factorial over 4 factorial. That is 15,120 rather. And then the total arrangements when there are no restrictions, that would just be Casablanca. And that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 factorial. And then we have 4 A's and 2 C's. So that's 10 factorial over 4 factorial times 2 factorial. And that gives us 75,600. So to get the total number of arrangements in which the C's are not together, we then say the total arrangements with no restrictions minus the total arrangements in which the C's are together. So if we punch that into our calculator, we get 60,480, and this would be our final answer. Part B. Find the number of different arrangements of the 10 letters in the word Casablanca which have an A at the beginning, an A at the end, and exactly 3 letters between the two C's. Okay, let me use a red color to represent the A at the beginning, and then we've got a C. And then here we should have 1, 2, 3 letters between, and then a C. So that's 1, 2, 3, 4, 5, 6 letters, 7, 8, 9, and the last one should be another A. So let's use red. So we have another A at the end. Okay, let's go back to our blue color and let's fill in the rest of the letters. So that is, we've got an A, an S, an A, B, and L, and then N. Okay, so that means we are rearranging only the items that have underlines. So that's 1, 2, 3, 4, 5, 6, 6 factorial. And we're dividing this by 2 factorial since the A's are repeating here in positions 1 and 3. And then we can rewrite this in 4 different ways. What I mean is, let me just erase those numbers at the bottom. Okay, we always have to have 3 letters between the two C's. So we could move the C to be here and the other C to be here, and we'd still have 3 letters in between. So if I'm just to draw that scenario on the side, that would be A, and then let's go back to blue. You'd have a letter here, and then we'd have our C, and then 1, 2, 3, we'd have our C. So that's 1, 1, 2, 3, 4, 5, 6, 7, 8. So 2 more letters, 9, 10. So you can see here that this is another scenario, but we could also even move the C's again. They could be moved further down the right, so that the C's are now in this position over here. And as you can see, we can simply count 1, 2, 3, 4, because at this position 4, the last C will be at the end here. So it means the 4 possible scenarios, so we multiply by 4. If we punch that into our calculator, 6 factorial over 2 factorial times 4, that gives us 1440, and that is our final answer. 5 letters are selected from the 10 letters in the word Casablanca. Part C. Find the number of different selections in which the 5 letters include at least 2 A's and at most 1 C. So we've got our word Casablanca, and what we want is at least 2 A's. So at least 2 A's. We have a scenario where we have 2 A's, we have a scenario where we have 3 A's, and we have a scenario where we have 4 A's. And then we have another condition which states that we should have at most 1 C. So what we're going to do is we're going to remove one of the C's from the selection pool. So that means if we remove that C from the selection pool, we will only pick at most 1 C, since we only have 1 C in our selection pool. Okay, so now we're picking 5 letters, 1, 2, 3, 4, 5. So we've already picked 2 A's. So that means we have 3 remaining slots for how many letters? Let's remove all the A's from the selection pool, since we've already selected the number of A's that we want. So that means we have 1, 2, 3, 4, 5 letters remaining for 3 slots over there. So that will be 5, choose 3, which is 10. And then the second scenario, we are picking 3 A's, and now we have 2 slots remaining for 5 letters, which is 5, choose 2, which is also 10. And then the last scenario, we have selected all 4 A's, and we have 1 slot remaining for 5 letters, so that's 5, choose 1, which is 5. If we tally up all the results from the 3 scenarios, that gives us 25, and 25 would be our final answer. Oh, that's the last question. So that's it for today's video. If you enjoyed the video, please like and subscribe for more videos like this, and comment down below which paper would you like to see me break down next. Bye bye.